Hello dear students, for today's lesson, let's talk about the t-distribution. What is the t-distribution and when do we use it? When sample sizes are small and often we do not know the standard deviation of the population, then the t-distribution or the student's t-distribution is used. This distribution was created by William T. Gossett, an Irish brewery employee. The t-distribution allows us to conduct statistical analysis on certain data sets that are not appropriate for analysis using the normal distribution. So basically, when n is small and the population standard deviation is unknown, we use the t-distribution. The formula in finding the t-score is this one, where bar x is equal to the sample mean. The Greek letter mu is the population mean. The small letter s represents the standard deviation of the sample, and the small letter n represents the sample size. Now let's talk about the properties of the t-distribution. First, it is bell-shaped and symmetrical about the mean, just like a normal distribution. Second, it is a family of curves, each determined by a parameter called the degrees of freedom, or df. The degrees of freedom, or the number of choices left after a sample statistic is calculated. Thus, it is given by the formula df is equal to n minus 1. Third, the total area under a t-curve is 1 or 100%. The mean, median, and mode are equal to 0. And as the degrees of freedom increases, the t-distribution approaches the normal distribution. If a normal distribution has a z-table, then the t-distribution has the t-table also. The t-values found in the t-table are the proportions of the areas in the two tails of the curve and are called critical values of t, or the confidence coefficients. These are the data you can find in that t-table. So the upper three columns in the table are the confidence level, or the level of confidence. The first column represents the sample size, and the second column represents the degree of freedom. The rest of the data represents the critical values of t, or the confidence coefficients. Let's have the first example, and we will determine the degrees of freedom and find the confidence coefficients of the given situation using our t-table. So number 1, at 95% confidence and the sample size n is equal to 11. First, let's solve for the degrees of freedom in the given situation. The degree of freedom is given by the formula n minus 1. So just simply substitute. Our n is 11, so that's 11 minus 1. Then our degree of freedom is equal to 10. Now, in finding the confidence coefficient, we need to make use of our t-table. Remember that our level of confidence is at 95% and our sample size n is equal to 11. First, let's find the level of confidence, which is 95%. 95% is located right around here. Next, the sample size n is equal to 11. So in the column of n, we find 11. Where these two values cross, that's our confidence coefficient. Hence, they cross at 2.228. So we can say that the confidence coefficient of the given situation, 95% confidence and n equals 11, is 2.228. Let's have the second example. So we are supposed to find the degrees of freedom and find the confidence coefficient as 0.99 confidence and n is equal to 25. So in finding the degrees of freedom, we use the formula n minus 1, substitute n, that's 25 minus 1, hence our degree of freedom is equal to 24. Now, in finding the confidence coefficient, we go back to our table. Remember that our level of confidence is at 0.99 and our sample size n is equal to 25. So where these two values cross, that's our confidence coefficient, or the critical values of t. So they cross at 2.797. Hence, we can say that the confidence coefficient of the given situation, 0.99 confidence, and n is equal to 25, is at 2.797. Next, let's talk about the percentiles in a t-distribution. The t-table can be used to find percentiles for a t-distribution also. A percentile, remember, is a number on a statistical distribution which is less than the probability in the given percentage. For example, the 95th percentile of the t-distribution with n minus 1 degrees of freedom is that value of whose left tail, which is less than, probability is 0.95 or 95%, and whose right tail, greater than, probability is 0.05 or 5%. Now, let's have this example and find percentiles using our t-table. So suppose you have a sample of size 10 and you want to find the 90th percentile of its corresponding t-distribution. So it's just actually the same with finding the confidence coefficient. We just use the t-table. We locate 0.90 on the confidence level and we locate the sample size of 10. So where these two values cross, that's the 90th, we can say that that's the 90th percentile. So they actually cross at 1.833. So the answer would be 1.833. Hence, the 90th percentile is equal to 1.833. We also use the t-distribution in finding the margin of error and confidence interval of our population mean. So the margin of error, denoted by the capital letter E, tells you how many percentage points the results will differ from the real population value. The margin of error is basically the range of values below and above the sample statistic in a confidence interval. Now, speaking of confidence interval, we use the margin of error in finding the confidence interval. The confidence interval is a way to show that the uncertainty is within a certain statistic. It helps you estimate the interval of your population mean. The idea behind confidence level and margins of error is that any survey or poll will differ from the true population by a certain amount. However, they reflect the fact that there is room for error. So again, we use the confidence interval to estimate our population mean. The following are the formulas used in finding the margin of error and the confidence interval. So T sub alpha over 2 is our confidence coefficient, S is our sample standard deviation, and the small letter n represents the sample size. The bar X represents the sample mean. Now let's go to our third example for us to understand further. So find the margin of error and confidence interval and interpret the result. Here's our situation. Anne wants to know if cooperative grouping is an effective strategy in improving the mathematics performance of grade 7 students. 20 students were included with a mean achievement score of 82.5 and a standard deviation of 3. The group comes from a normally distributed population, adopting a 95% confidence level. Remember that in this problem, we are asked to find the margin of error, the confidence interval, and we're going to interpret the result. So first, let's find the margin of error. So to find the margin of error, let's start with finding the given. So first, let's have the sample size. The sample size is 20 since there are 20 students. Next is the sample mean. The sample mean is 82.5 and our sample standard deviation is equal to 3. Now, the confidence level or the level of confidence is at 95%. So first, let's solve for the degree of freedom given by the formula n minus 1. We will just substitute n equals 20, so that's 20 minus 1. 20 minus 1 is 19. Hence, our degree of freedom is 19. Next, let's find the confidence coefficient, T sub alpha over 2. So we actually use the T table, and remember that our n is 20 and at 95% confidence level. So we just locate the 95%. Now first, n is equal to 20. It's right over here. And our confidence level is at 95%. right there. So where these two values cross, that is the value of our confidence coefficient. So they cross at 2.093. So our confidence coefficient or critical value of t is 2.093. Now let's solve for the margin of error. It's given by the formula confidence coefficient times standard deviation over square root of n. So we just simply substitute. Our s is equal to 3 and our sample size is equal to 20 multiplied by the confidence coefficient 2.093. So 3 divided by square root of 20 is 0.6708203932. Multiply it with 2.093. The answer will be 1.4040278083. We round it off to up to 2 decimal places. So our margin of error is equal to 1.40. Now let's solve for the confidence interval of our population mean. Remember that our solved margin of error based on the sample size 20 is 1.40. So we use the formula. The population mean is between sample mean minus E and sample mean plus E. So we just simply substitute. Our given sample mean is 82.5 minus the margin of error 1.40 and 82.5 plus 1.40. So we just simplify. 82.5 minus 1.40 is 81.1 and 82.5 plus 1.40 is 83.9. Hence, we can say that the population mean is between 81.1 and 83.9. Now, in making interpretation, we say with 95% confidence level, the interval between 81.1 and 83.9 contains the true mean achievement score of the grade 7 students based on the sample of 20 students. So that's it for today's lesson. I hope you learned something about the t distribution. Always remember, have a statistic amazing day.